Hello, everyone. Just confirming. I'll give around 5 minutes, so 12:35 before I actually start. Hi again, everyone. Thanks for joining. So we'll probably get started with some introduction while the rest of the people are joining. So as mentioned on the description of the webinar, this is not a Kubernetes specific session, but basically some experience we had at Fastlane with Rancher on doing some implementation of it. I'm gonna keep everyone on mute. Please ask questions on the questions panel if you have them. I'll try to get as most of the questions I can at the end of the presentation. And there is Igor Cole also working for Fastlane. He'll be checking all their questions. So if there's something we can respond in the meantime, he'll do so.
Yeah, and please keep an eye on the chat window. I'll be there, and I'll be there helping if you have any issues with anything.
Sure. All right. So I'm Felipe. So I've been working for Fastlane for 3 years. How we started working with Rancher was basically back in September 18. We started working on the project, which is the project that I'm gonna give the example on this presentation on how we did things there. Then beginning of the year, we had some discussion that would be good to work on a partnership, and we got some Rancher training, which was one of the first, or actually the first APAC official training from Rancher. And then we got the partnership officialized July this year. Unfortunately, we don't have anyone from Rancher who could join specifically today, but if there is any question that is more product related and we're not able to answer, we will reach them and come back to you via email. So what we're going to cover, basically some context of the project where Kubernetes was used, just a brief description of what is Kubernetes. Again, the idea is not to explain the cores of Kubernetes or anything like that, but more on how the roadmap of implementation works and how Rancher helps on it. Some drivers we use to define that Rancher specifically should be used. What was the evaluation we've done and how we selected the product. and some considerations on the enterprise implementation specifically, and also on the architecture. And then finally, some overview of Rancher, and we do have some Rancher running to show a little bit on how it works, and then we're going to open for Q&A. Okay, so this is just to give some context and timeline of this particular Rancher, implementation. So in that particular client, we started working with them back in end of 2016, provisioning CI/CD tools as we usually do. So just to give some context, in Fastlane we work with agile transformations, CI/CD automation in general, and non-functional testing. So particularly for the client, that's how we started with agile. Then we were called to work with them on CI/CD, and that CI/CD bit for the particular request was finished back in February 17. Then we started doing some other portfolios, and the client decided to start using Spring Boot microservices back in June 17. Around September, they already have 5 of them in production. Then that kept growing until recently. In the meanwhile, also we did Docker Swarm POC, because back then microservices were running as standalone Docker. So we decided to try to see what are the advantage of Docker Swarm were. We did have some issues with performance on Swarm of the box load balancing. That's when we decided to park the POC, and also when we started looking at Kubernetes. Given that back then, mid last year, most of the providers, like cloud providers, decided to go with Kubernetes. We thought it was best to evaluate Kubernetes because that was pretty much the chosen, let's say, platform or orchestration platform for Docker back then, and most likely still the same. Even I think 1 or 2 days ago, VMware announced that they're working on that as well. So then that pretty much that evaluation, coincidentally, there was a hackathon at the client where the team was resilient. So it made sense to show a few of the Kubernetes capabilities. So we show the main ones in a 5-minute presentation, and with that, Kubernetes won the hackathon, which gave some funding to do the official, let's call, non-production implementation, and that's what we're going to talk about in the next few slides. All right, so this slide is just talking a little bit about the drivers. You could see that in many Kubernetes, say, products, the way they describe the capabilities, and that's why we've chosen it. So these are the main ones. But of course, this is not an exhaustive list. So among them, we should talk about auto healing and scaling, load balancing, and not only load balancing, but also integration with a few of the enterprise load balancers, particularly the one the client was using back then. The way you can deploy those workloads, basically by default, you already have like a Bluebeam type of deployment, which is really beneficial, causing no outage on services in case there's any issue. On top of that, which is not very much related to resilience, but it would also bring the benefit of managing configuration and also secrets, aka password and keys, in a centralized manner, also as a code. And finally, logging and monitoring, where I wouldn't say specifically Kubernetes, but Rancher or the product will give us that out of the box, also with some integration of the main vendors, and same thing for the logging. So how that evaluation happened? So there were a few things. Basically, the main one was the capabilities. So of course, we could go ahead and install vanilla Kubernetes ourselves, but even a year ago, there were a lot of options that were providing that in a very easy manner, and also more importantly with PCI, DCS compliance and 24/7 support. So if you did it, if have done vanilla Kubernetes, we wouldn't get that, so it wouldn't even make sense. So with that in mind, we said, because we need a vendor anyway, or a product that does that, let's just get one that is easy to set up and use. Also one that has a good user base to make sure that's not going to, say, disappear in a couple of years. And finally, cost. Of course, this was important, but we need all the above before we can actually look at cost. So then finally, we had a list. Initially, that list had open source products, and some of them didn't provide any kind of enterprise support. So we did test a couple of them anyway, but in the end, the ones that actually went through all the criteria and we could test them and get a feeling on how they work were pretty much 5 of them. I can recall the other 2, but the final list, which had the main candidates, was pretty much the OpenShift Container Platform, Docker Enterprise Edition, and Rancher. So just backing up a little bit. So within that, the main reason why Rancher was picked up was number one was because back then we didn't have any commit to production implementation funding, which means if we chose either Red Hat or Docker and decided to stay only with the non-production without any license, we didn't have that option. So with Rancher, what we could do is we could do most of the tests using the open source version, and then it's just a matter of engaging Rancher and now saying we're a supporter after paying for the license, of course. So that gives a lot of flexibility, and also if that's even the case in the future, if you decided not to pay for support anymore, you can still use the same product. And moreover, it's using vanilla Kubernetes, which means we can even stop using Rancher at all. So that was pretty much the main point on choosing Rancher back then. So a little bit of the setup that has been done. Bear in mind that this was what has been done was here pretty much that first line, which is the non-production cluster. So for both production and non-production, the architecture was, whenever working with high availability, would have at least 3 VMs running a particular component, and one would be basically the client had 2 data centers, so 1 VM in each data center plus 1 in AWS. Usually people who go straight for cloud would choose in AWS, for example, 3 availability zones, but that was not the case, because one of the main things about implementing Kubernetes and using Docker in the data center is because we could make more usage of the data center and make that more efficient. So that's why we're not going straight to cloud. But again, that also could be stretched to cloud if needed. So pretty much the idea is, in case the data center was pretty much over capacity, we could stretch the cluster to the cloud very easily. And then basically in the non-production, we would initially have a single cluster. That's what has been set up. And that cluster will be pretty much separated in what we call non-production environments. So say dev, test, and UAT as an example. And then we would have a production cluster, which may be separated in also some namespaces like pre-prod and prod. So that was the idea behind it. Some other things that we had to consider, of course, was first one is by installing Docker and Kubernetes, pretty much that configuration had to be CIS compliant in order to go to the security audits. For Docker, we did use inspect profiles and to check for that compliance. For Kubernetes, Rancher had pretty much the hardening guide from them, which is already actually pretty much all the YAML configs to set up Kubernetes that were already CIS compliant. It's important to say that Rancher gives support for the whole stack, which means if you're using Kubernetes with Rancher, pretty much you have support on their product, Rancher. They also support you on Docker layer and even the operating system layer if that particular operating system is supported by them. Then we also use some add-on to integrate the workloads with the load balancer, which at 5 in that particular case. We also had to consider scanning the Docker images. So pretty much we had to scan the images during the build and before deployment and also in production to make sure they didn't become vulnerable. That particularly is not yet supported by Rancher out of the box. They're working on it. And during that period, we were using Claire. That was the thing used to do that scanning. For PCI and non-PCI workloads, basically the segregation will be having at least for production, actually only for production, nodes in PCI zone, which would have pretty much taints for PCI, and then we would work so that only those workloads would run that tolerate that kind of taint would run on those nodes. And then finally, the last thing was we also wanted to version control not only the configuration of the Kubernetes pods and services and etc., but also the secrets. And for that, we use something called kubectl. And then, so with that in mind, just before talking about Rancher again, so Kubernetes just giving the orchestration layer on top of everything Docker, right? But then once you start creating multiple Kubernetes cluster, then how do you manage multiple cluster, and also how do you provide a common layer for pretty much everything operations and security, role-based access, and everything else, right? So that's when Rancher comes in. So it helps with all those things, not only that, but also security policies and things like that. So with that said, just showing a little bit more of the capabilities. So apart from giving that user interface for all the cluster, you could easily attach your managed clusters to monitoring logging tools, also giving alerts on top of that monitoring. You can build your own service catalog if you intend so. Basically, that's based on something called Helm, which is kind of a package manager for Kubernetes, where you can have things that have dependency between them. And then on the operations side, you can actually see your whole cluster, and you can also apply authentication, policy, and security capabilities across all those clusters. And then how that integrates to other platforms. That pretty much can be integrated to most of the cloud providers, not only for cloud managed clusters, but also to bare VMs on the cloud on which you can deploy Rancher on top of. Then this slide, I'll try to go a bit quickly, but apart from the capabilities that has been shown on the previous slide, Rancher has some other capabilities and some capabilities they're working on. And then some of them here that I would like to point out is Longhorn, basically giving the distributed storage capability, which is very important on a Kubernetes cluster. And that's what we were intending to use in that particular client. ICO for pretty much the service mesh, image scanning, as I said, so multi-cluster app, which is, I'm using the alpha version here, so you can already see that in my screen. Submariner for multi-cluster communication networking, and some other things that are still coming, as you can see. Just a little bit about Rancher. This is back in December 2019, and it's been growing exponentially. So that has probably changed a lot since then. But basically, you can see most of the presence, of course, as U.S. companies in the U.S. But we do have presences here in APAC, and mostly in here you can see like in Australia and even New Zealand. You can also see that it's the most widely adopted Kubernetes platform. So as I said, the main factor for that is because it's open source, right? And it's you don't need to pay for a license to start using it, but you may choose to do so later on for enterprise support. Here also a few of the clients. Some of them you can notice are Australian clients. I'm not sure what there's anyone in the audience outside Australia, but those are pretty much the clients. Okay. All right. Let me check the questions and answer for now to see how does it look like. See if there is any particular question. And then I will go to, I'm going to explain what we're going to cover on the demonstration. Okay, nothing there. All right, so I'm going to continue. So this is what we're going to cover on the demonstration. Here on the left side. So I'm going to try to explain briefly, and then I'm going to actually show the things on the screen. So basically, we're going to show the setup of video, and then I'm going to show on the actual Rancher cluster where a few of the capabilities. Okay. So before I jump to the video on how the Rancher is provisioned, so pretty much what we have is for the first bit here we need RKE which is basically one of the Rancher tools that the Rancher provides to provision a Kubernetes cluster. Is we need a VM to provision that, at least few VMs to provision that cluster to. So in order to do that, we're using Terraform to create those virtual machines in AWS. And then on top of those virtual machines, the only thing we're installing on them is Docker. So that's the only thing being done. Then once we have those VMs, we use RKE to provision 2 clusters. So looking at this image, you can see here the Rancher cluster. So basically Rancher runs on top of a Kubernetes cluster. So we create a separate cluster only for Rancher, those 3 VMs here. We also create another cluster using RKE again, which will be what we're calling a development cluster, where we're going to actually install workloads. Also notice that for Kubernetes cluster, we have only 3 VMs, which basically when you're doing some Kubernetes setup, you should have the masters. So I'm not going into the detail of that, but basically the management of the cluster in the masters, and you shouldn't run workloads on them. Because they're very CPU intensive and you don't want to break that cluster. So, but for the Rancher installation itself, that's fine because Rancher is the only thing that is going to run the cluster. So that's why we have 3 VMs, which are masters and workers or nodes at the same time. But then for the non-Rancher cluster, the dev cluster, we have 3 VMs, which are the masters, and then we have, just for this example, 2 workers, right? So, and then on top of Rancher, we have basically some Nginx load balancer, which is just pointing to the Rancher VMs to do just basic load balancing. And the domain that I set up is using AWS Route 53, right? So that's pretty much the setup. So with no further ado, let me just open the video. Just give me 1 second. All right, so as you can see, we start with a single instance called here Docker Nginx, which will point to the cluster. And that IP address is pretty much what we're going to be. And that machine actually is the one I'm using to provision everything because it's already sitting in AWS. So the process of provisioning machines with RKE is very simple. Pretty much you just give the IP addresses, the key, the private key, and also you tell the number of the role of that instance, if it's a master, a worker, or both. So what I have there, I have one script that actually creates all the EC2 instance using Terraform, as I said. Then what I do is I have a kind of a helper script, where I put all those IP addresses, and what they're going to do in the end is they're going to run RKE, right? So this is what you see now on the screen, me updating that wrapper script. That's pretty much going to do the RKE calls, okay? So once I have the IP addresses, one of the things I did was, just going back slightly, was I just updated the Nginx config. So what this script is doing is just going to that particular instance and updating Nginx conf with the Rancher IP addresses, right? Nothing more than that, because they do provision and they provision that all the time, and those IPs are provisioned on the fly. So you can see that my domain is pointing to that particular IP address. You can see the Rancher is not running. And of course, those machines were just recently provisioned, which means they don't have nothing on them, as I said, just Docker. Now what I'm going to do is, because the machines are already running, I have to pretty much set up the cluster. So that's when RKE is running. So all this log here is from RKE. So what it's doing is creating that particular Rancher cluster. So you can see that the first cluster is already there. Another thing we have to do on that cluster is, because Rancher is installed using Helm, which is the package manager, we have to install Helm on that particular clusters before we actually can install Rancher on it. So that's what's happening now in that screen. Once that is done, pretty much we update the Rancher repository and install Rancher using Helm. So you can see that what it's doing as a default is trying to spin up 3 instances of Rancher, and it's saying it's done with that. So that means we should now be able to access Rancher. So it should now be available, which is the case, right? So this is how you set up Rancher and how you set up a Kubernetes cluster to put Rancher on top of it. But now what we want to do is we are also provisioning some cluster called that cluster, and we want to make sure that cluster is also managed by Rancher. So once that script is done, which should be in a while, we're gonna pretty much import that cluster. That's how we call in Rancher. So you can see that the local is the cluster where Rancher is running with 3 nodes. And then once the dev cluster is ready, what we're going to do is click on Add Cluster and then import. And then we're just going to give it a name, say here dev. And just, it's going to give us one of the Kubernetes commands. So given that we are pointing to that particular cluster with our command line, we just run that command, and what it does is pretty much does everything to connect that cluster to Rancher. So if you skip this one a bit, you can see that the cluster is finished, and I'm also installing Tiller on top of it as a default. And then finally, what I can do is I can run that command that was giving me on the screen, and it's gonna import the mean now that that cluster can be managed and can also be managed by Rancher. So I'm going to show a little bit more on the actual screen, but yeah, that's how I set up the cluster that is running right now. Okay, so going back to the demo, so now what we have is we have all these boxes set up with Kubernetes, and we have Rancher on top of them. So another thing I have done, otherwise conscious of time of the webinar, I wouldn't have time to do it live, but what I've done is to better show the capabilities of Rancher, I have installed OpenLDAP, and I did install OpenLDAP using the Rancher apps. This is just for authentication. I have also enabled monitoring. That's out of the box Rancher. It's just a matter of you enabling it. And then, which is by Grafana, with Grafana and Prometheus. Also, I have installed via Rancher pretty much the DFK stack for Elastic Fluentd and Kibana to do the logging. So we can probably see some example where we're going to run some workload, and that's going to be picked up at Kibana. And then finally, I'm going to show how easy it is to provision some example service and how easy it is to create a simple application or chart when you're talking in Helm terms. All right. So now back to Rancher. So this is the actual live version that I have. You can see that it's actually the same. So we have a dev and a local cluster. So talking about the first thing which we mentioned was pretty much talking about cluster namespace management. So we have here 2 clusters, right? We've already been there. That cluster is the cluster where I probably want to do my things. The dev cluster and all cluster by that mean already have, when created by RKE, have something called system, which is basically running all the Kubernetes and Rancher relevant processes, which you shouldn't be touching ideally. And also creates a namespace called default, right? And default is where actually you should be running your workloads. So you can see now that actually there is already something running here, and the reason it's running is because when I set up this cluster for the demo, I installed an app. I installed an app called ESK, right? So that app pretty much is running our Kibana, which I'm using for the logging. I'm going to go into that detail later. What I want to show now is that when I'm in the dev cluster, when I go to namespaces, you can see the namespaces I already have here. When I go to the actual cluster, I also have kind of the same idea, right? And one thing that Rancher does, and which this is not Kubernetes thing, but it's Rancher to make sure we're doing role-based access, is we have projects and namespaces. So basically what you do is, given a project, you could do roles and permissions on that particular project and then associate that with namespaces. So the only way you can manage and do things from Rancher within the Kubernetes cluster is that namespace is attached to a project, right? So what I could do here is, for example, create a namespace called dev inside the default project if I wanted to. Yeah, and you can also see that you could set quotas for those namespaces, and that's very important when you're doing something like creating a non-production cluster for multiple environments. So you should be able to limit the resources for each one of those silos, right? So that's the thing about managing clusters and namespaces. Also about clusters, another thing we have is if you go to the dev cluster, you can see that this is being monitored by Prometheus and Grafana. So what I've done is for that particular cluster, when I started Rancher, I went to Tools and Monitoring. And then there was an option here, Enable. That's all I've done, okay? Of course, that the implication of that is if you do that by default, it doesn't have any persistency, which should be fine for a demo and even be fine for a maybe non-production cluster. But that's, of course, not ideal for a production cluster, but you could potentially choose that for the production grade installation, right? So that's all I've done. And what that does is basically it gives you this view over here where not only you can see what it's reserved. So when you deploy something in a Rancher cluster, pretty much you want to reserve some amount of CPU and memory for that workload. But by having the monitoring enabled, we can also see what's actually being used, right? So that's very important for capacity planning. So that's for the monitoring, and of course you can go to Grafana and see all the details. You even have some capacity planning here, so that's actually good to see things that are happening, right? And then for the logging, as I said, I have installed that Kibana stack on the dev cluster. So if I go to the Kibana, I should be able to see some of the logs of the cluster. So let me open that. And here you can see the live logs coming, right? So to make that more interesting, what I'll do is, again, before that, I will show how I did that integration. So for that cluster, basically what you have to do is, again, go to tools, and now instead of monitoring, you go to logging. Then I selected Elasticsearch and pointed to my actual IP address, right? So very easy. And after that, the data was already being digested by Kibana. So then what we can do is, going back here to our demo, is we could create pretty much a service and show that whatever is happening is being logged there. So what I can do is I come to Rancher and go to my default cluster. And then there is an option here called deploy, right? And as George does, let's take it easy and just do some Nginx example. And what we want to do is we want to show that that's actually available. So let me just exposing some ports here. And after a while, we should get a port available to check that Nginx. And there you go. So this is how you could potentially deploy an app. Of course, here this is not using HTTPS, right? But you could install pretty much the Cert Manager add-on on Kubernetes, provide your TLS certificates, and you could easily have a DNS-based service with SSL certificates. So that's not very hard to accomplish. So then, now that we have Nginx, so we gave it a couple of tries here on logging, on refreshing the page. So in a couple of minutes, we should be able to see that here in the Kibana. So I'm just refreshing that. And then here we have Kubernetes pod name. So it's still not there, but it usually takes a little bit of time to be reflected here. We should get it in a second. So what I'm going to do in the meanwhile is I'm also going to do some invalid attempts here of accessing non-system page to get some 404, so that we can also see that from there. And also I'm going to show another way of provisioning workloads in Rancher, which is using apps. So again, apps is using pretty much the Helm concept. The important thing about it is you can use what Rancher called catalog. So you have the library, which is the Rancher created Helm chart, and then you have Helm stable and then Helm incubator. So I have enabled all of them just for me to see all the apps available, but ideally you should probably stick to Helm stable and library, and maybe creating your own enterprise repo if you want to. So what I'm going to do is I'm going to go to apps, and I'm going to go to default here, and I'm going to also try to provision something more complex than Nginx, and also a very common example, maybe some WordPress. So I'm going to use the library one. I could choose many options here, but I'm just going to try the default one. And while that is happening, let's see if we got the Nginx logs here in Kibana. We do have Nginx, so I'm going to select that. And then if I wanted, I could look for that 404. So I can actually see those access I tried to make to the test web page. Excuse me. So you can see here pretty much the call I've made, right? /test and 404. All right, going back to WordPress, it's still provisioning, but maybe I cannot already show what's going on. So as I said, the app or the Helm, it can create a lot of things, not only a single pod, right? So particularly WordPress, it needs a few things to work, right? So first thing is a database. So you can see here it's setting up MariaDB, and that looks like it's already active. And then because WordPress depends on it, so now that the DB is active, it's actually starting up WordPress, and WordPress seems to be live. Before I jump into it, you can see that it actually set up some other things, the service, which allow us to access that externally without pointing to a fixed IP address. It also set up config maps and secrets, which is basically whatever configuration you need to do to bootstrap that particular workload. And then we should probably be able to go through that. And again, similarly to what we've done for Nginx, we should be able to see our WordPress workload running here. So now instead of checking for Kubernetes, for Nginx, I'm going to check for WordPress. Still not here, also because I do have some kind of search. Let me clean that up. Yeah, we do have WordPress, so I could also check that. All right. So pretty much that's what I wanted to show. So let me just check if I didn't miss anything. So we're going through how to manage cluster, add a cluster, create new namespaces, role-based access control. Actually, you can see I'm logged in with some user that is not admin. And the way I set this up is by using OpenLDAP, and the way I enabled was going to global security authentication. And you can see that I'm actually using some OpenLDAP that actually is even running inside that cluster, right? So it's also very, very easy to set it up. You can also add groups to the project, give permissions, give granular permissions. It's very, very flexible. All right, so just let me check before I show anything else if there is any question. So I see a question here from Andrew. So what's the pricing model for renter? So I won't be able to give the pricing. That's not on their website, and it has been updated in July. So I don't have the latest prices. What I can tell you is how the licensing works. So basically the way Rancher charges, so basically there are two main things to look at. One is if you need 24/7 or 8x5. That's the first kind of level you're looking for. Second thing you're going to look for is if that's a production or non-production cluster. So basically the way it works is non-production price is half of production. That's how it works. And then in terms of components, the way to separate that, and I might open the slide to show that better, is you have to pay a fixed price for Rancher installation. So say you have a Rancher installed in non-production and another Rancher installed in production, you're going to pay two of those licenses. You can have from 1 to 7 VMs on there, on nodes. Let's call it nodes. So that's only to run Rancher, right? So you're paying for Rancher essentially. And then the rest of the cost of the license is in terms of nodes that Rancher is managing, right? So that doesn't matter if that node is it's a master or a worker. So what's going to happen is, in this particular example, is you buy, the way you work with those licenses, you buy what, but don't think that changed, but you buy packs of 20 nodes. So here what happens is we do have 5 nodes. So by buying a pack, we'll be fine, right? We'll still be able to create 15 more nodes. So you keep buying those 20 node packages, and that's what you pay for. And again, you pay for non-production and production. Of course, you could choose to not having a non-production license at all. That's also an option. So keep that in mind. And another thing you can do, but I have to confirm if that hasn't changed, is basically, say you're getting production and non-production Rancher, and you paid for production 20 nodes, but you're not using all 20 nodes in production. So say you're using 5 in production and 15 in non-production. You can only pay for 1 pack. That's doable, right? So if you're not using your whole pack in production, you can use part of that for non-production as well. Is that okay, Andrew? So Andrew, I'm gonna just put you on. I'm gonna take you out of mute. It didn't get very well. Okay, you got it. Okay, cool. So this is how it works. What I'll do is I'm gonna send an email for everyone with my contact. I'll be happy to get that information if you need the pricing. Okay. And is there any other question? Let me check here. I don't see any other question. All right. So assuming there is no more questions, of course you can raise any other questions, or if you still want to know more about Kubernetes and Rancher and how can help your organization, you can contact me directly via email, and then if needed, we can also make a call or something like that. But that's it. So thanks everyone for joining. Hope you have a good day, and I'll be wrapping up. I'll give 4 more minutes in case anyone has more questions. Thank you all.